In today's session, we're gonna learn about Numpy. Numpy is short for numerical Python. In Python, there are many mathematical functions and numerical operations, and they are packaged together in Numpy. So Numpy is a package that is normally not loaded when you load Python. Numpy is a data structure. It's also known as ND array or n-dimensional array. N is a number. N can be 0, 1, 2, 3, 4 or more. Normally, N is used as 1 dimension, 2 dimension or 3 dimension. So 1D array, 2D array or 3D arrays, these are common. Okay, but it can be more than 3. So when we say ND array, that means n-dimensional array. To start using Numpy, we have to import Numpy because by default Numpy is not loaded in Python. So we use the keyword import and then Numpy, and this part is optional as NP. Numpy becomes NP. It's easier to use, so we can say import Numpy as input. If we don't use as NP, then instead of NP we have to keep using Numpy. So when we want to use Numpy, we use the word Numpy or use the word NP. We can use the word NP if we say import Numpy as NP. And then we can use different commands that are supported in Numpy. In bracket, we're gonna pass different parameters as well. We can create an array. So this command can be different command. One command is array. So np.array will create an array of 6 items here. So this array is very similar to a list. And then dot a command name np.command. So np.array will create an array, and inside parentheses we can give a list of items. Okay, and they are separated with comma. So this creates a one-dimensional array, and it is a list. In fact, okay, a one-dimensional array is a list. We can also create two-dimensional array. Here is an example again, np.array, and then one row, comma, another row, comma, another row. Okay, one row, 4 items, comma, second row, 4 items, comma, third row, 4 items. So it essentially has 1, 2, 3 rows of items, and we can start creating. So here we start with input. Okay, to use Numpy we have to start with input and then Numpy, and we can use as if we wish. Okay, and then we can create an array with numpy.array. Remember numpy.command. So this array is a command. Inside bracket we can pass a list. So 2, 3 is a list of 2 items. This creates an array. However, to hold it we need to put in a variable. So let's say array is equal Numpy, and then if we print that array, this array will be printed. This array is the same as a list, so we can also use index for it. For example, if I put 0 index, it will print the first item. Okay, only 2. If we print the 1 index, then it will print the second item. Okay, index 0 and index 1. So if I say 1, then it will print this one. Okay, sometimes many people use import Numpy and then as NP. It becomes easier when you use as np instead of numpy, now you say np. We are saying numpy as np, and then since then we're going to use np. So it gives you the same result. You don't need to type in the big word numpy. You can use any, in fact anything, but np is the common. So if I say n, I can also use n. So it's I'm giving a name to numpy. Okay. Why do we import? Because numpy is not normally loaded in Python and many other libraries that are not by default loaded. So to use them, I need to import. Numpy is one example, and you're going to see other import examples in future classes. So commonly we use np. So I'm going to use np. So it creates a one-dimensional array, which is like a list 2, 3. If I add more, 4, 5, 6, 7, 8, and then if I want to print all of it, I can print array. It will print the whole array. If I want to print any specific item, let's say index 3 means fourth item, 0, 1, 2, 3. So this is the fourth item. It should print 5. It printed 5. Right? Now we can create a two-dimensional array. To create a two-dimensional array, we'll put one list in a square bracket and then comma another list in another square bracket. So 5, 6, 7, and then both of them in a square bracket. And then if I print the array, now you see it has arranged the first list of items in a square bracket came in the first row, and the second list of items in the square bracket came in the second row. Okay, this is a two-dimensional array. So one square bracket, one row, and comma another square bracket, another row. Okay, if I want to add one more, that will create a third row, still two-dimensional array. Let's say 8, 9, 10. So first row, this is the first row, okay, comma, second row, comma, third row. So this is a two-dimensional array. It has 3 rows. This is row number 1, row number 2, row number 3. However, if you think in terms of index, that index is also represented by using row and column. So number 2 is on row 0. It starts actually from 0 when you say index. So this is 0 row and 0 column. Okay, so this 2 is 0 row and 0 column. If I print, now I have a two-dimensional array, right? So I will have to mention a row number, first a row number, and then a column number. So if I say 0 and then 0, that will be 0 row and 0 column. So that crosses at number 2. So that gives you number 2. Let me print the whole array first. Now you can see this is the whole array, and then I printed like an index, but since it's two-dimensional, I have 2 values now, okay, separated with comma. And the first one is row number, so this row, and second one is column number, so this column, which indicates number 2. If I want to pick up this one, that would be row 0, and column 1. So row 0 and column 1 will give you 3. Okay, so here you will get 3. I got it 3. Row 0, this is row 0, and then column 1. This is column 0 and this is column 1. So row 0, column 1 indicates this number 3. If I go to 1 1, then row 1, so the first row is 0, so this is second row now. Second row, and then column is also 1. This is column 0 and this is column 1. So when I go to row 1 and column 1, that indicates number 6. So if I run, I will see 6 here. Alright, this is a 2-dimensional array. If I make a 1-dimensional array, it's easy. Array 1 equal np dot array, and then in bracket list of 0 1 2 2 3 4, print array 1. Okay, and then let's make it array 2, print array 2, array 2. You see this is 1 square bracket and list of items, so this is the same as list. Here we have 1 square bracket, comma, another square bracket, comma, another square bracket. So that makes a 2-dimensional array. First row, second row, third row. So this is this one, 0 1 2 3 4. Okay, so printed array 1 0 1 2 3 4. We'll say 1 dimension 1D, and 2D. Okay. So 1D array this one, 2D array, because they printed 2D, this line moved. Okay, that may be just I'll put in a different row that will be aligned. 1D, 1 row. Okay, 1 row, and how many items? That many column. 2D, 3 rows, 3 columns. Each row has 3 items. Each row has 3 items. Row number 1, row number 2, row number 3. Okay, alright, turn this off. So this is how we create a 1D or 2D arrays. Let's see. It's exactly the same thing. So here is data 1. Data 1 means this part. The same as I can replace data 1 with this, right? I can replace data 1 with this. Is the same thing. If I turn this off, and then np.array, and then list of items, and when they print, you see those numbers or the list of items in a 1-dimensional array. Okay, now 2-dimensional 2D. So I have an outer square bracket. Here is outer square bracket. Okay, this one and this one, and then I have inner square bracket 1 comma 2. So this is gonna be the first row, and this is gonna be the second row. So you can see this is the first row in the output. When I create array 2, the first row and then the second row. Now there are some other command that you can use. Actually, there are characteristics. For example, NDIM, n dimension, it indicates the dimension. Okay, if if you made an array2.ndim represent how many dimension it has. So it will give you two-dimensional. Since it's two-dimension, I created that's 2. Also, shape tells you how many rows, how many columns. You have 1 row, 2 row, so 2 rows and 1, 2, 3, 4 columns. So 2 rows and 4 columns. Okay, if I go there, n dimension. Okay, array dot ndim and shape gives you how many rows, how many columns. Array dot shape. It's dimension 1. Okay, 1 row, so dimension is 1. Shape 5 items. Okay, 5 items in 1 row, there is no column. 5 items in 1 row, that's what shape is. But if I do this for 2-dimensional array, now array2 dot dimension, array2 dot shape. You see, this is the 2D array. Its dimension is 2, shape is 3 by 3. That means 3 rows, 1, 2, 3, and 1, 2, 3. If I change it to 4, let's say 0, and let's say 4, and add one more item. Okay, now we have first row 1, 2, 3, 4, second row 1, 2, 3, 4, third row 1, 2, 3, 4. If I run, you'll see the shape now changes to, it's 2 dimension, that means it has rows and columns. There are 3 rows and 4 columns. There is 1, 2, 3 rows, 1, 2, 3, 4 columns. Okay, if I want to print out, for example, only this 10, I will need 0, 1, 2. So we need 2 as a row, and column is 0, 1, 2. That will give you 10. This number 10 coming from here. Okay, 0, 1, 2. So row number 2, the first comes row number, and then comes column number 0, 1, 2. So that gave you 10. If I say 1, 2 and 1, then 0, 1, 2, and then 0, 1. So I will expect this 9. If I run, I will expect this 9 as output. Alright. Now n dimension tells you an array dimension, whether it's 1 dimension or 2 dimension. Shape gives you the number of rows and columns. Okay. Also we can have a 3D array. 3D array is a multiple 2D arrays separated with comma. Okay, let's take a look at here. When you say array shape, and it's a 1D array, it gives you how many items are there. There are 9 items here, 0 to 8. That gives you 9 items. So shape gives you 9 for a 1D array, one-dimensional array. Okay, but if I go for two-dimensional array, now shape gives you number of rows first, 1, 2, 3. So 3 rows, and then comma 1, 2, 3, 4, 5. Okay, index starts from 0, but we are counting, so you're saying 1, 2, 3. Okay, don't confuse with index. Index starts with 0, but when you say how many, we count from 1, right? 1, 2, 3 row, 1, 2, 3, 4, 5, 5 columns. So this is a 3 row, 5 columns. The shape returns 3, 5. This is a 3-dimensional array. It's like a different plane or papers. Okay, one paper is like your 2-dimension, and then you're putting one paper behind another. There are multiple 2-dimensional array here. That's 3-dimension. When you indicate any specific number, let's say number 6. Number 6, if you want to say number 6, first you have to say which page it is on. Okay, which page, not the row and column. First, which page. So page number 0 at the front, you can say this is the front, so page number 0, and then row number is 0, 1. Okay, and column number is 0, 1. So 0, 1, 1 gives you number 6. If I say number 12, again page number 0, and then row number is 0, 1, 2. Okay, and column number is 0, 1, 2. So 0, 2, 2. If I say number 13, then page number 0, and then row number 0, 1, 2. Okay, number 2, column number 0, 1, 2. So 0, 2, 3 gives you number 13. So if you look at 3-dimensional array, if you look carefully, you will see these are actually two-dimensional array. Okay, so this is a 2-dimensional array, comma another 2-dimensional array. So this is like one page with first row, second row. Okay, and then another page. So these two are one page, first row, second row, first column, second column, third column. If I say index, 0 row index, 1 row index. Okay, and then 0 column index, 1 column index, 2 column index on the first 2-dimensional array. And then second 2-dimensional array, you can think it's a page behind the first page. So when you start with the second, that means the index starts with the 1. First one's index starts with 0 on the first page, and then you say row and column as the 2 other numbers. So when you print this, it will show, let's take this numbers. Array 3 equals np dot array. I started with this one, and then I think there is some tab character or something is getting error. Okay, from PowerPoint, that's why it's showing error. But if I just fix the spaces, that should be fine. So here we think this way. First I want to create one 2-dimensional array, which is this one. Okay, so one row, comma second row. Okay, so this is a two-dimensional array. As you saw, two brackets, one bracket close, another bracket close, another bracket close, and then finally the closing square bracket, opening square bracket. Similarly here we have opening square bracket, closing square bracket for this two-dimensional array, and then comma, another two-dimensional array, and then finally we have everything enclosed with another square bracket. This one is the start, and this one is the finish. Okay, and array parameter. So array 3 has become a three-dimensional array with the first row, second row on the first page, first row, second row on the second page. Okay, so page is like something like this: first row, second row, and then behind first row, second row. So if I see the dimension, okay, array dimension, then it will say the shape dimension and all those things. Array 3, it will say the dimension is 3. I will not print this one anymore. So the dimension is 3, and look at this, the first number indicates how many pages. Okay, so pages are like 1, 2, 3, 4 pages. Okay, and one page is a two-dimensional array. When you think about a two-dimensional array, this is a one page. Okay, so and it has 3 rows, 5 columns, right? 3 rows, 5 columns, 3 rows, 5 columns, one two-dimensional array, another two-dimensional array behind, another two-dimensional array behind, another two-dimensional array behind. So the shape, the first number actually indicates the number of pages or number of two-dimensional array. So if I make another page, okay, if I add one more page, inside here, so I added another two-dimensional array. So I have 1 page, 2 page, 3 page. This will change to 3. As you can see now, change to 3. Okay, so this didn't look okay. This should be 4, and then 3, 5. Okay, this should be 4, 3, 5. Well, it's an image, so I can't change it for now. Anyway, so here, shape, when you have a three-dimensional array, here you can see three-dimensional array. This is a two-dimensional array. It started with this square bracket, ended with this square bracket. So that's a two-dimensional array, and then another two-dimensional array. Okay, and then whole thing is put in a square bracket starting from here and up to here. So when you say shape, it gives you 1 page, 2 page. That's the first number. Okay, so that's the 2 pages. 1 page, 1 page, 2 page, and then in each page, so look at one page now. In each page, there is 2 rows, 3 columns. 1 row, 2 row, 1, 2, 3 column. 1 row, 2 row, 1, 2, 3 column. Okay, so that gives the shape. We can create an array of zeros by using the function zeros. Zeros is a Numpy function. So if I go here, we've seen 1 dimension, 2 dimension, and 3 dimensional array, right? And then let's say array 4 equal np dot zeros. And if I want to make one-dimensional array, then I will put one number, so there will be 6 zeros. Okay, and then print array 4. Zeros. Okay, np is numpy, np.zeros 6, so there are 6 zeros, 1 2 3 4 5 6. Now if I put two numbers, so that's going to be a two-dimensional array with all zeros. So this is going to be 2 rows, 6 columns, so like 2 rows like this. I need 2 brackets. So since it's a two-dimensional, okay, 3-dimensional still you need 2 brackets. You have now 6 zeros on the first row, so this is number of rows, number of columns, okay, and all fill up with zeros. So 6 zeros, and second row 6 zeros. If I make another number, it's a 2. So 3-dimensional array, first page, and then row, column. Okay, first page, number of pages, 2 pages, and each page will have this many rows, this many columns. So if we make a 3-dimensional array of 2 pages, each page has 6 rows and 2 columns, then you'll see 2 pages. Okay, this is page number 1, this is page number 2. You can say this is at the front according to this visual representation. This is at the front, and this is at the back, or this is the 0 page, and this is the 1 page. 0 page has 6 rows, 1 2 3 4 5 6. Each row has 2 columns, 1 2. Second page also 6 rows, 2 columns. Okay, so we have 2 pages, 6 rows, 2 columns. If I make 3, again 2 pages, 6 rows, 3 columns, 1 column, 1 increase. Also we can use ones. In that case, this will fill up with 1 instead of 0. Now we have ones. Okay, a quick way to put some numbers and create an array. This is 3-dimensional. From here up to here is a 2-dimension. From here up to here is another 2-dimension. So 2 2-dimension or more than 1 2-dimension makes it 3-dimensional. We can have more dimension as well. There can be also different operations in arrays. Created an array with 1 2 and 3 numbers, and then printed the array times array. Okay, it's gonna multiply each item of an array with the same item of the same array. Array minus array, each item will be right from the same item of the other array. 1 divided by array, 1 divided by each item. So 1 divided by 1, 1 divided by 2, 1 divided by 3. It will create an array of this. Array to the power 0.5. Now if you look at the result, so we have initially array 1 to 3, print the array, so printed 1 to 3, and then array times array, so 1 times 1, 2 times 2, which is 4, 3 times 3, which is 9, and then array minus array, so 1 minus 1, 2 minus 2, 3 minus 3, that means 0. Now 1 divided by array, so 1 divided by 1, 1, 1 divided by 2, so 0.5, and 1 divided by 3, so that's 0.33. Okay, now next is double asterisk sign, indication of power. So when we have 1 to the power 0.5. Okay, if I open calculator and then 1 to the power 0.5. Okay, that gives you 1. 1 to the power 0.5 is 1. Okay, and then 2 to the power 0.5. It takes each element and do the operation. So 2 to the power 0.5, that gives you 1.4142 here, and then 3 to the power 0.5. Okay, 3 to the power 0.5, 1.7321. Alright, now index and slicing. In lists we have done index. So similar concept here. Essentially a one-dimensional array is a list. A range, we have used range before, but np.arange gives you the same result. Np is numpy, right? Numpy.arange gives you 10 numbers starting from 0 and goes up to 9, increased by 1. Okay, so when you print that array np.range 10, that gives you an array of 0 to 9. Now index again starts from 0. So when you say index 5, 0, 1, 2, 3, 4, 5. So this number 5 came here. And then this is slicing. Start index 1 less than this index. So 5 to 7. Index 5 to 7. Index, this is 5, 6, 7 index. So 5, 6, 7. Okay, this slice, the starting index is 5 and ending index is 8, but not inclusive, so that goes up to 7. And then we are changing a slice's value to 12. The starting index 5 and ending index 7 inclusive will change the value to 12. So the 5 position, 5 index, 6 index and 7 index all change to 12. You can create a slice and then put in a new array. So this is like an array that we got from the array slice 5 to 8, not inclusive. And then this is a new array. In this new array, changing the one index, which is the second index. So index 5 was the first index, or index 0 of the slice, and in the slice second index would be index 6 of the original, right? And when you take a slice and change the slice, here changing the slice one index, so you took the slice 5, 6, 7, which had all 12 initially. We had 12, 12, 12. Remember in the previous page, 12, 12, 12. So these three numbers were taken, 5, 6, 7 index, and this is the slice, and put it in a new array called array slice. Now out of this array slice, we're changing index 1. This is the index 1, okay, of that slice, and it turns to 1, 2, 3, 4, 5 a number. It's not multiple number, it's one number. Okay, it's changed to this value. And then when you print the array, not the slice, you're printing the array, you see the array has changed. You see the array has changed. Okay, and then also we're changing the array slice. Remember, when you put a slice, you use two numbers separated with colon. So first index and last index. But if you skip both of them, then it means all items. So array slices all items will turn into 64. So all these three items will turn into 64. Here the key point is, when you make a slice and give it a new name, make changes in the slice that affects the array. Now we have a 2D array, row 1, row 2, row 3, row index 0, row index 1, row index 2. When you have a 2D array and while printing you give just one index value that takes the row number. Okay, so you're saying row number 2, essentially row index number 2, 0, 1, 2. So that's 789. So that gives you 789. And then when you put two numbers, either by using two square brackets, here you can use two square brackets, or you can use one square bracket and two numbers. It's the same. Okay, these two are the same. So you're saying 0 row and 2 column. So this is 0 row, 0, 1, 2. So this is the 2 column. So that gives you 3. Okay, if I say 1, so if I say 1, so 0 row, 1 column. 0 row, this is the 0 row, and 0, 1 column. This will give you number 2. If I say 2 row, okay, and 1 column, so 0 row, 1 row, 2 row, and then 0 column, 1 column. That will give you number 8. This 2, 1 is the same as, you can put two square brackets side by side, no comma, and then put row index, column index. The first number is the row index, second number is the column index. Or you can use one square bracket, first number comma second number. First number is the row index, second number is the column index. Now when you have a 3D array, this is a 3D array. Remember, 3D array has multiple two-dimensional array. So this is the first two-dimensional array, second two-dimensional array. First two-dimensional array is, you can say this is page number 0 and this is page number 1. When you say only one index, that means the page number. So first you printed all of the array. So this is all of the array. Okay, I put an extra space. It is printed all of the array. Second, you printed page 0. So this is page 0. 1, 2, 3, 4, 5, 6. Page 0. Okay, and then printed page 1, which is from here to here is the page 1. From here to here is the page 1. So printed this one. If you supply just one index in a three-dimensional array, that indicates the page number. I'm calling it page, it's not really a page. Just to understand better, from here you can see this is the front is the page 0, 1, 2, 3. This is not the right shape though. Be careful about that. The number 4 should be at the beginning. 4, 3, 5. There are 4 pages, 3 rows, 5 columns. So it should be 4, 3, 5. Now when you have 2 dimension, the first number indicates the row, second number indicates the column. So there are 3 rows, 5 columns. You have 3 rows, 5 columns, 4 of them. So number 4 5 should be the shape. So let's take a look at here. We have a two-dimensional array, okay, and then when we are mentioning 0 to 2, but this 2 is not inclusive, so 0 to 1, okay. Remember, 0 to 1, it includes the row number 0 and row number 1, so that's why it's indicated with red shade, okay. Row number 0 and row number 1, and then in the column area, comma, then comes column area. Column area, when you don't mention anything, then it includes all of it, right? And then here, the second example, look at the first number is saying row number 2. So it's coming row index 2, 0, 1, 2, row index 2. But on the second dimension, columns, it says start from 1 and go up to the end. So it is starting from 1 index, which is number 11, and going up to the end. So this look at the color match. So the first number indicates the row, second number indicates the column, but you can slice also. So first number, not just one number, you're putting slice. 0 to colon 2 means 0 and 1, not including 2. Okay, so 0 row and 1 row. And the column wise, it didn't mention anything. It's colon, just a colon. That means starting from 0, it goes up to the end. For example, here after colon, it didn't mention anything, so it goes up to the end. If I skip the first part, it starts from the 0. So in this example, row number 2, so 0, 1, 2, and then column number starts 1, so 0 is not taken, starts from 1 and go up to the last. Here another example, the row number started from 0 and also goes up to 1, not including 2, so 0 row and 1 row, okay. So 0 row and 1 row. However, for column number 2 or 2 index, 0 row and 1 row, this is 2 index and 3 index. I'll show you in the 2D array here. So let's print array 2. We're focusing on 2D, okay. So array 2 with dimension, the first number comma second number, we can do that way. So if I say we have 3 rows here, right, 1, 2, 3 rows. So let's say row number 2, so 0, 1, 2, row number 2. Column, I'm taking from 1, so I put a comma from 1 and then colon. I'm not mentioning anything, so I expect it will go up to the end when I print this, okay. No, I'm not. Okay, let me print the whole array first also, then we can compare side by side. So I'm printing whole array first and then printing this part, and we are skipping. Let's not focus on this, so I'm gonna disable, okay, disable. Now if I run, these 3 lines were the first array, and then I said row number 2, 0, 1, 2, column number starts from 1, so column number started from 1 and did go up to the end. Now if I say 1 and 2, again row number started from 2, okay, so it will come on this row. Column number started from 1 and up to 2, but not inclusive 2. So 1, 2, 1, okay, not included 2, 1, 2, 1. That gave row number 2 but column number 1 to 1, not included 2. When you have a 3D array, you print just one number in the index that gives you the page number. Okay, so if I go back to and use 3D array, this is 3D shape. Let's say array 3. We're going to print array 3. Okay, array 3, and then I'm giving only one number, so let's say 0. That's going to print started from here, and then so 2D and ended 2D, one 2D array here. So when I print 0 index, so this is the first page, it will make a two-dimensional array of this page. So 1 2 3 4 5 6, that is what expected. 1 2 3 4 5 6. Okay, and then I'm going to turn this off as well. If I print array index 1, so it's gonna skip the first page and then it's gonna take the second page. Okay, and it will print 1 2 3 4 5 6 again. Let's change a little bit so that we know what is happening. 10 20 and 30, suppose, and 40 50 60. So this is page number 2, and you say 1, that will give us 10 20 30 40 50 60. 10 20 30 40 50 60. This is the second page. First page, not just a list of 2 rows, row number 1, comma, row number 2, and then put both rows in a square bracket that gives you one two-dimensional array, and comma, another two-dimensional array starting from here up to here, and then third two-dimensional array starting from there up to here. So I can go 0 1 and 2. Okay, so this will give the last one. Let me change 1 1 and 2 2 3 3 4 4 5 5 and 6 6. So it's easy to distinguish. Okay, now I'm printing the page index 2, so third page. All right, we have seen indexing. So a range gives you 10 numbers, 0 to 9, and you are slicing 1 to 6. However, 6 is not included, so 1 index, 2 index, 3 index, 4 index, 5 index. So this is the output of this slice. Okay, if we skip the first number, it starts from 0. So this is a 2D array, 0 row and then up to 1 row. So 0 row and 1 row. So this is the output, 0 row and 1 row of this print. The first print is printing all of it. The second print is printing 0 row and 1 row. Third print, now I'm mentioning two indexes, first index, comma, second index. But in the first index, I'm saying 0 to 1, not including 2. So saying 0, which is row, so 0 row and 1 row. Okay, first 0 row and 1 row. However, in each row, start from 1 column, not 0 column. So 0 row, 1 row, 1 column up to the end, 1 column up to the end. So that's why you see 2 3 and 5 6. 2 3 5 6. More examples, the same thing. You can, and then T does transpose. Transpose means row becomes column and column becomes row. So this 1 2 3 4 becomes column. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4 was a row. In a two-dimensional array, you transpose means each row becomes each column. So one row, first row becomes first column, second row becomes second column, third row becomes third column. So you can do transpose, okay, and after you transpose, the number of row we had 3, and that's why dimension gave you 3 and 5. Now when you transpose, it gave you 5 and 3. You can multiply array with array. If you do, then each item gets multiplied with each item. For example, array times array means 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. Also, you can do reshape. So first it creates 9 numbers, 0 to 8, and then 9 numbers are rearranged into a 3 by 3 two-dimensional array. Okay, 9 numbers are reshaped, 0 to 8, reshaped to 3 by 3 two-dimensional array. You can use few other things. For example, here a list of 4 random RANDN gives you 4 random numbers including negative. Okay, again for random numbers including negative, this is x, so the first line is x, second line is y, and then you say maximum of x and y, so that will give maximum of the first item in both array. This is negative, so negative 0.9 and negative 0.03, this is bigger, so maximum is giving you this one. Since it's negative, 0.3 minus 0.3 is bigger than minus 0.9, and then it's getting maximum of these two, maximum of these two, maximum of these two, and so on. So there are different functions. Add, so you have two arrays, one array, one dimensional array, another array, and then when you add them, it's adding this one with this one, first item with first item, second item with second item, third item with third item, and so on. You can do sort, simply array name dot sort, okay, and sort along the row and sort along the column. So this is the original. So when you do sort with the 0, so that sorts along the column, okay, 1 8 3, so 1 3 8, 3 4 5 3 4 5, 2 9 8 2 8 9. So when you say sort 0, it sorts along the column. When you say sort 1, it sorts along the row. We have discussed this and some more graphical presentation of what we have discussed, and I'm going to finish here. Alright, take care everyone.